Dear students, welcome to the course Network Theory. In the previous video, we solved two problems on source transformation, right? So how a voltage source in series with resistance can be converted into current source in parallel and vice versa. Okay. So today we will see the second variety in the source transformation, that is source shifting. Okay. Problems. Okay. So note down the problem. So using source transformation and source shifting techniques, find voltage across 2 ohm resistor for the circuit shown in figure. Okay, so this is the network. You have a 3 ohm which is in parallel with again 1 ohm and 4 ohm resistor. Then in between you have 2 ohm resistor is connected with this branch, 2 amps is connected, and here 3 volt source is connected. Okay, so now, so you pause the video and note down. Okay, I will continue. So how to solve this problem? So is there anything like previous problem so that you can have a current source in parallel or voltage source in series? We can solve it. No, right? So we could not do, right? So what we need to do is source shifting we have to do first. Okay. So where we can do source shifting here easily. So if you look at here, node A and node C. Okay. And node A to node C, what is connected? 2 amp current is connected. And how it is going through? It is going through this path, right? So this within that it is attached, right? So now this current source can be splitted, right? So from A to D we can split, and from D to C. So instead of going from A to C, so we'll make A to D and D to C. So this is called as source shifting. Okay, so that will show you in next step. So note down this problem when you are solving problem. This is a question, right? So again, when you are writing on the answer paper, so you need to write down the first given question. Okay, so this is what I told you. Remaining nothing I am changing. So it will be as it is. Okay, 3 volt, 3 ohm, this 1 ohm, 4 ohm. Okay, so this again I have shifted. Okay, so this I have not shown you earlier, right? So there was a 3 volt here. Just there was a 3 volt here. So this was just pushed through this and this. Okay, so both thing we have did. Okay, so this 3 volt is pushed through the node B. So it comes through 4 ohm also as well as through 3 ohm. So in the theory part, I have explained this in source shifting, or E shift, right? The same way we are doing voltage shift, and this current is divided here. Okay. So just go through the figure. Okay. So this clear. So it was plus minus over here. So it will come plus minus here. Okay. Which is in series now. Okay. So again here, this current source is in parallel with 2 ohm. Now this 2 amp is parallel with 1 ohm, and this voltage source in series. So now this is in a form so that you can apply to some source transformation. That's why the problem is called source shifting and source transformation. Okay. So now, so next what we can do, so just we'll convert only this branch. Okay, so one by one we'll do it together. It will be difficult. Just try to convert this current source in parallel with resistance into a voltage source in resistance. So then what will happen, starting from this path, okay, to till here. Okay, so this path will be one branch so that we can simplify that. So then we'll see how the picture comes, and then we can further continue, right? So just note down this. Okay, so we'll convert this. Remember the current source, how you make voltage source, V equal to IR. So 2 amp into 1 volt is 2 volt. So 2 volt in series with 1 ohm resistor. Okay, so this is what you see. Okay, and which side current direction is there? Okay, which side you have the arrow mark, we'll write plus, and tail where you have, we'll write it as minus. Okay, so remember this. Okay, so now you have a circuit here. You can apply from here this node to this node, only this. Okay, this branch, this complete one branch. Now no other element or branch is connected, so that, so this is in series now, 3 ohm. Here it looks like parallel, but this is a single wire. It is denoted like this. So this is a single wire, 1 ohm, then plus minus 2 volt, then you have a 3 ohm. Okay, so this is 2 ohm, this is 3 ohm, and this is 2 volt. Okay, how they are connected as it is. Okay, this is in sorry, minus plus it was, just a minute. So sorry, I made 1 ohm. This is 1 ohm. After that, with the same direction will go. Minus plus is there, then 3 ohm, and then here plus minus is there. So just observe the direction. Okay, plus minus. So now you have to simplify this. So 3 plus 1, how much? 4 ohm. And now this minus plus 2 volt, and this plus minus 3 volt is there. So whichever is having highest value, will keep that notation plus minus. And now you have to subtract this. 3 minus 2 is 1 volt. Okay, so that will show it in next figure. So try to think. Okay, go through the concept. If you have not understood, it is very simple. Okay, so now topology wise we have connected like this. Okay, instead of going round, so now we have made simplified. 3 plus 1 4 ohm came, and 3 minus 2 1 volt. Okay, so that is what this is about. Okay, whichever is having highest value, that same notation we have kept. So this was there earlier, 4 ohm 3 volt. So now it is like this, and there was a 2 amp current source in 2 ohm. So now you have to think. Okay, so we can convert this into voltage source in series, or convert this voltage source into current source. Okay, so as per experience, as you solve experience, so it is understood that, so if you have voltage source in parallel, you could not do any operation. In the first problem only you understood, right? So that's why what we'll do, so all these branches are in parallel now. Okay, so these two and these two all are in parallel, so we can make it as a single line, and we convert this into current source now. So this is as it is, we are not going to touch this. We will make current source now. So current source V by R, 3 by 4 amps, and this is 1 by 4 amps, and 4 ohm resistor will be in parallel. Okay, simple one. So then that circuit will be shown next. So see, this is how the final simplification came to from first circuit. So this is as it is, we have not changed. 2 amp in parallel with 2 ohm. So this is the voltage source we converted into current source, V by R, 3 by 4 amps, and 4 ohm as it is, which is in parallel. Then 1 volt was there, 4 amp was there, so V by R 1 by 4 amps, and this is 4 ohm. So now the circuit is simplified. Okay, so 3 current sources are there, just as first problem. Just add up all the 3 current sources, and there are 3 resistances in parallel. Use the elements in parallel. Okay, so resistors in parallel formula and calculate this. Okay, so here current source easily you can calculate. 2 amps, 3 by 4 means 0.75, 1 by 4 means 0.25, both together it is 1 plus 2 3 amps. So current source you are going to get 3 amps without any calculator help. Then you calculate the resistance, so that will be shown in next step. Okay, so current you came it as 3 amps. R equivalent, so we need to find out. Okay, current is 3 amp. 1 by R equivalent equal to 1 by 2 plus 1 by 4 plus 1 by 4. So half plus quarter plus quarter, so it is straight away you without calculator by simple, it is 1 ohm, right? So it is 1, so R equivalent is 1 by 1 is also 1 ohm. Okay, so that's why, so you'll get 3 amps, and the R equivalent is 1 ohm. So that is what substituted, so the complete circuit become now single circuit. So now what you have to calculate here, voltage across 2 ohm resistor. So that 2 ohm only we have simplified and become 1 ohm resistor. So finding out that, so what we will do, just Ohm's law, V equal to IR. So in the circuit you have I and R, just multiply these two. So 3 amp into 1 ohm is equal to 3 volt. Okay, so this is the problem. Okay, so using source shifting first, and then applied source transformation, and then elements in series, elements in parallel. Okay, so this is the hierarchy, the problems will be solved. In case if you does not understand, go back and check once again. Okay, so we'll go and see one more problem like this, source shifting. Note down this. Reduce the network shown in figure to a single voltage source in series with a resistance using source shift and source transformation. Okay, so just see the question also here. First question I asked you the current through a load resistor. Second also it was current. Third question I asked you voltage, right? So like that different way they can ask the question with respect to circuit parameters. Now this fourth question also observe, they are not asking any voltage or current through a resistor, but reduce the network into a single voltage source in series with a resistance. So no need to find out any value, just you have to bring the final circuit. Okay, so how they are asking question like that only you have to present your answers. That is also important in numerical problems. Okay, so now note down this network. You have A and B terminals. In between, the elements are connected in this fashion. Okay, so 2 ohm, 5 ohm, and this 45 amp. So this is like a triangle shape here. Then here 8 ohm, 30 volt, and 10 ohm. So this is like a rectangle. And again you have 3 ohm, 6 ohm. So this is one triangle. Okay, so this is the shape. So note down this. So how to solve this problem now? Again, if you see, look at the problem, is there any straight away you can do transformation here? No, right? It is difficult. Okay, so that's why you have to look off the source shifting. So if you look at this again, current source, so from here to here. Okay, so this current is going, whatever coming from to this node will be reaching the node same. So 45. So this we can split it like this, right? So it is, sorry. Okay, so like this we can do. So it will be going to this node, and from there it is going to this node. So then current source in parallel with this resistance, and here nothing will be there. It will be removed in the case of current source. Similarly, you have a voltage source here. It is also not in parallel with any series with any resistance. So it should be pushed here. So this is the node through which we have to push that. So how pushing means two direction you have to push. So one is this direction. Okay, when you push like this, it will come as plus minus in this place. And same way you have to push in this direction also. So what will come there? Here it will come minus plus. Okay, so this should be very careful when you are pushing through the node and doing shifting. Okay, so this I will show you next step. So note down this question once again when you are solving. Okay, so this is the transformation I did with respect to current source. So this is now made 45 amp in parallel with 2 ohm and 5 ohm, and here this is shifted here. See, plus is there, minus, and here it came minus plus. So now if you look at the circuit, so here current source in parallel with resistance. So you can do source transformation. Similarly here you can do source transformation. After that you can add here, simplify. Again here this is there. Okay, so but not go together if you are not understood. Okay, so just we will try to do this step. Okay, at least these two will do transformation first. Okay, so step by step we will go. So this step will be shown. So what is the voltage source here? V is I into R. So 45 into 2, 90 volt. Similarly here 45 into 5, how much? Okay, use the calculator and find out. So how much it is coming, you write down that much voltage, and resistance will be in series. We'll show that in next step. So if I'm going fast, you pause the video and note down the, okay, so draw the network. Okay, okay, so this is what you got, minus plus. So whichever side arrow mark is there, this head side we will write it as plus, and tail side we will write it as minus. Okay, similarly here plus and minus. So now this is one complete circuitry. Okay, till here to till this node, there is no, nothing is connected in between. And similarly here to till here, it is one branch now. So whatever is connected now series, so we can solve it. Okay, so here 2 ohm resistor, 8 ohm resistor, so it is 10 ohm. So that 10 ohm is written over here, and here minus plus 90 volt, and here plus minus 30 volt is there. So whichever is highest, 90 volt, so that notation we will write first, minus plus, and we will subtract now 90 minus 30, 60 volt. If you have to write plus minus, then you can write plus minus, and you have to write here minus 60. Okay, so that is also you can do. Okay, similarly the bottom one, so same way 5 ohm and 10 ohm are in series. So straight away 10 plus 5, 15 ohm you can write, and there is no voltage source connected here. So same voltage source I am placing over here, 225 ohm. So another side what I have, so this is a parallel, right? So that's why this parallel connection is not connected straight away here. So it is shown as a another branch. So now what you have, 30 volt in series with 3 ohm, which is in parallel with 6 ohm. Okay, so this is not changed as it is. Okay, we have written. Okay, so what is the next step? So obviously you voltage source in parallel, you could not do any calculation as per first problem, right? So convert this into current source in parallel with resistance, current source in parallel with resistance. This is also current source in parallel with resistance. So then you will get some simplification. Okay, So what you will get current here, I V by R. Okay, so 60 by 10 is 6 amps, and here 220 by 15 is 15 amps, right? And observe here, minus plus is there, so your current direction will show like this. Here you have plus minus, so your current direction should be like this. So you will get opposite side currents in this question. Okay, similarly here you will have minus plus, so current direction will come like this. Okay, so just we'll show it in next step. Okay, so we are almost at the end. So 60 by 10 6 amp, this is what I told you. Direction is this way. 10 ohm is in parallel, resistance value does not change. 225 15 is 15 amps. Okay, I mean, so now see the direction here. Okay, this side 15 ohm resistance. Similarly here 30 by 3 10 amps, so direction here 3 ohm 6 ohm. So what you have to do here, parallel resistance is there, so you need to solve it. Okay, first parallel resistance 10 ohm 15 ohm, here 3 ohm 6 ohm, so both calculation are shown below that, and current source can be subtracted here. Okay, so whichever direction you are referring, so this highest current 15 amp, you keep this arrow only 15 amp, subtract 6, what is the value, 9 amps. Okay, if you want to use this notation, so you need to write minus 9 amps. Okay, so that is the difference. Okay, okay, so we'll solve this. 1 by 10 plus 1 by 15, 30 is the LCM, so 10 3s are 15 2s are, so 5 by 30, so R equivalent is 30 by 5 equal to 6 ohm. Okay, similarly this R equivalent is 1 by 3 plus 1 by 6, 6 is the LCM, so 3 2s are and 6 ones are 2 plus 1 3 by 6, so if you take the reciprocal 6 by 3, you'll get the R equivalent. Okay, so note down this value. Okay, so now we'll go to next step, so we'll write this. Okay, so 15 minus 6 9 amps is in parallel with 6 ohm, and here 10 amp is in parallel with 2 ohm. Okay, so that is the simplification we will get. Okay, so this is the last step. So 15 minus 6, and this is the same direction which is having highest value. Okay, that only I have written this direction, 9 amps and 6 ohm, what we have solved equivalent resistance 10 amps in parallel with 2 ohm. So now we are almost at the last step. So convert this into voltage source in series, again voltage source into series. Okay, so voltage source V equal to IR formula. So 9 into 6 40 54, and the direction here is this side arrow mark is there, so that's why plus minus. Okay, this side plus, this side minus, value is 54 volt. 6 ohm is in, comes in series with that. Similarly here 10 amp and 2 ohm, so 10 into 2 20 volt. Now the direction is minus plus here because of the arrow mark. Okay, so this 20 volt and then 2 ohm is in series. Okay, so what is the question asked very first? Reduce the network to a voltage source in series. So that is what the last step is about. Okay, so now add up this. So this is having plus minus and this is having minus plus, opposite, so you could not add straight away, so this is the confusion you will make. You have to subtract here. Okay, so whichever is having highest, so that polarity I am writing plus minus first, subtraction value 30, 54 minus 20 is 34 volt. Okay, 6 ohm and 2 ohm are in series, so just add up, it will be 2 ohm. So the final is between, so whatever the network you have seen very first between A to B can be reduced to a simple network with a 34 volt in series with 8 ohm. How this is possible? By the method of source shifting and source transformation. Okay, so this is about the first topic from the module 1, and we have solved almost the important questions here. And in any additional problems I will give it in assignments. Okay, so before you answer the assignment, so you should thorough with this all the problems and theory part. Okay, so assignment also promptly you have to do. Okay, and it should be within the time. Discipline is more important. So if you late submit, so whatever so far recordings are done, how many classes are done, that will be taken as absent, and your grade for internal assessment also will be reduced. Okay, so no marks will be given if you submit late. Okay, so I will tell you in the group, so when I give the assignment or upload in Google Classroom, if you are not joined there, so join. Okay, those who are not joined, join. Okay, so go through these 4 problems. Okay, so this is the first set. Okay, very simple. So next we will consider in the next video source uh, star to delta transformation. Okay, thank you, we'll see in next video.